part when trying to kind of work backwards to find a value is making sure we understand what numbers we're supposed to use. And that's what we're going to practice in this example. It says, for a medical study, a researcher wishes to select people in the middle 60% of a population based on blood pressure. If the mean systolic blood pressure is 120 and the standard deviation is 8, find the upper and lower readings that would qualify people to participate in the study. Again, draw a bell curve and see if you can kind of plug things in. Remember, our mean's always in the middle. In this case, it's 120. We want the people in the middle 60%. So we want 60% around the middle, 30 on each side. That's going to give us kind of the range of blood pressure numbers that we want. Think about the standard distribution curve. I'm sorry, the standard normal distribution table. The numbers on there represent the percentages under this curve. So if I were to do a rough sketch here, real rough, and focus maybe just on this first value right here. I'll use this as the first one. What we're talking about is the percentage up until this value. What we have to remember is this line right here in the middle, the mean, that's going to be 50%. And I'm going to actually write it with a 5 with a bunch of zeros after it, kind of because that's what we tend to do. 50% of the data lies up until this line. To get to this point, we're actually adding on another 30%. Okay, so go from here to here, that's another 30%. So to get to this point right here, we're actually wanting to know what 80% of the data is. And again, that's the tricky part when we're using the table. Those numbers all in the table, they're representing those percentages, those probabilities, however you want to think about it. How much of the area under the curve, that's what those numbers are. So to get to this first value here, we want to know 80%. 60% around the mean, 30 on either side. The mean's 50%, half the data, half the number of people with these blood pressures, 30% on either side. So if you go to your standard normal distribution chart and you look at the positive side, because, well, we're to the right of our mean, the closest thing you're going to find to 0.8 or 0.8000 is going to be, kind of write it down here, the closest is going to be 0.7995. Okay. Remember how we read that on the table is that's going to correlate to 0.84. And if I had a picture of the table, you remember you'd come out here to the 0.8 and it'd go up. Oh, I'm sorry, this right here would go to 0.8 and this would go up to 0.04. Okay, so we know our z-score is 0.84. That's a z-score that correlates to almost 80%. Now, we want to be able to find the value with that. So use your formula. And remember, we did have this new formula here. So we can say, I'll write it up here, our x1 is going to be the z-score times the standard deviation plus the mean. Plug things in. Z-score 0.84 times our standard deviation, that's right here, 8, plus our mean, that's right here, 120. It gets our first value, the positive value over here, to be 126.72. Alright, so that's going to be this value right here. Now let's find out our x2 value. Sketch another really bad curve here. This one, again reading from the left, we want to figure out what this value is right here. Remember, here's 50% of our data, and we have 30% to over here. So that means this right here, this is going to be at 20%. 20% of the data is going to lie up until that second value that we want. So this is going to fall on the negative side of the chart. because we're below the mean. And the closest to 20% or 0.2 is going to be 0.2005. And that occurs at the z-score of negative 0.84, which kind of makes sense. Again, if you look to your left, you get negative 0.8. You look up, you get 0.4. Do the same thing we did here. To find our second value we're looking for, take the z-score, I'll write it down real quick, times the standard deviation plus the mean. Our z-score is a negative 0.84 times our standard deviation, same standard deviation, 8, same mean, 120. You figure this out and you get 113.28. What does this all mean? Remember, a researcher wishes to select people in the middle 60% based on population. So the middle 60% are going to have blood pressure readings from 113.28 to 126.72. This will get easier, as with everything, the more you practice it. But having that understanding that the numbers on our standard normal distribution chart represent basically the area up into a certain value. Once you can kind of grasp that, we can figure out these values using that table, correlating it to the z-score, and then using our formula to eventually get us to the value.